In applications around the world, we use heat engines all the time. It starts out with the steam engine, internal combustion engine, etc. The basic principle of a heat engine is that it takes advantage of the heat flow from a hot reservoir to a cold reservoir. In nature, heat typically flows from hot to cold on its own, and heat engine takes advantage of that heat flow. It diverts part of the heat flow and does the work. The efficiency of an engine can be defined as the ratio of how much work is done by the amount of heat that comes out of the hot reservoir. The equation is defined as how much work it can do divided by the amount of heat used on the heat transfer. The more you can divert to work and the more efficiency the engine becomes. Also, we can determine the amount of work as the difference between how much heat we get from hot reservoir and how much heat is expelled, which is this equation, which also the efficiency equation can become this equation. Now let's work an example. An aircraft engine takes in an amount of 8,900 joules of heat and discards an amount of 6,200 joules each cycle. What is the mechanical work output on the engine during the cycle? So the given values are QH, which is equal to 8,900 joules, which is the amount of heat, and QC, which is the heat that is discarded, which is 6,200 joules. So we subtract that, which gives us the work, which is 2,700 joules. So what is the thermal efficiency of the engine? We use this equation, which is work divided by heat, which is equal to 2,700 joules over 8,900 joules, which is the total heat, which is equal to 0.3033 times 100 is equal to 30.3%, which is the thermal efficiency of the engine.